Welcome to In 5 Minutes. We have just now discussed the circuit diagram of balanced modulator. The balanced modulator takes two input signals which were in the form of modulating signal and the carrier signal. So in the previous video clip we have taken these two signals as V1 and V2. My V1 was the carrier signal and V2 was modulating signal. Now let us try to understand how exactly we could achieve only the two sidebands and we did not get any carrier signal at the output side. To understand that first, we will quickly consider the expressions for V1 and V2. V1 was the carrier signal Vc cos 2 pi fct and V2 was the modulating signal Vm cos 2 pi fmt. Now, if you can recall from the previous video clip, there were two diodes and we were using the non-linearity between the input and output signals. And because the way we had made the connections on the input side, both the currents through the diodes were flowing in the opposite direction. So the equivalent output current was difference between the two. And when we take that difference, all the similar terms were cancelled out and the terms which were differing in the negative sign, they were added. So if you can have a look at that particular expression, if you can simply recall it, you will observe that the main operation that was taking place in my final output signal was of something of this form. We had used a constant A and I was getting V2 on the output side in the form of modulating signal. Now please remember that this is not so important term. We in fact don't want V2 to come in the output side. We are only interested in the second term. In the second term we had written in this form B. I kept that 2 extra 2 outside because later on I was going to use the formula of cos A cos B. And after this constants we actually had the two signals being multiplied, V1 and V2. And we had also, to keep things simple, we had clubbed the peak amplitudes of V1 and V2 inside the constant B. So I can say that later on I had taken my signal V1 as simply cos 2 pi fct. We can assume Vc to be 1 and V2 as cos 2 pi fmt. So I'm just assuming peak amplitudes to be 1 for simplicity. So this is the most important operation because we could multiply the two signals V1 and V2. So immediately in the next step we could write V1 as cos 2 pi fct and V2 as cos 2 pi fct. Because we could multiply them, I could use formula of cos A into cos B, and this further gives me the two terms which were in the form of fc plus fm and fc minus fm. So if you observe, the most important operation taking place is this operation, which is nothing but the multiplication of the two signals. So because we could multiply the two signals which are modulating signal and the carrier signal, because we could multiply them, when you multiply the two frequencies, you generate sum and the difference of the two frequencies, which is due to the simple trigonometric identity which says that 2 cos A into cos B is cos A plus B plus cos A minus B. So when you multiply two cosine signals or two frequencies, you generate their sum and the differences. And sum and the difference is exactly my upper and lower sideband frequencies in case of AM signal. So if I can simply multiply the two signals, I can generate double sideband. There will not be any carrier and hence it will represent double sideband suppressed carrier. So this is what we are doing with the help of balanced modulator. So balanced modulator in simple words simply acts as a multiplier. It multiplies the two signal and it multiplies them because of the very special feature which is non-linearity, which is in the form of diodes. It could be also in the form of transistors. And using this, it is generating the two sidebands without any carrier coming at the output side. So we conclude that balanced modulator simply acts as a multiplier. So henceforth, please remember that whenever we draw a block in which we are mentioning BM or balanced modulator, it will always take the two input signals and those two input signals will be multiplied on the output side. We will neglect this first term because we have modified balanced modulators in which we can also get rid of the first term and the output will be pure multiplication of the two input signals. So balanced modulator will be used as multiplier in many communication systems. In digital communication systems also, many places when we want to multiply two analog signals, we use a balanced modulator. So please remember, the moment I draw a block with balanced modulator, it will simply multiply the two input signal.